Hello everyone, thank you for joining me. My name is Massi, I'm from Philos team and here to talk to you about F3 Aware Lotus APIs. So today we're going to talk about what is F3, why these APIs matter to builders, take a look back at evolution of Filecoin APIs over the years, take a deep dive into V2 APIs and talk about what's coming next. So what is F3 anyway? F3 is a consensus enhancement to Filecoin network. It is outlined in FIP 86, which is linked in the QR code there. The current finality on Filecoin network is called EC, Expected Consensus. It is a probabilistic model and based on the distance from head, which is 900 epochs or 7.5 hours. In practice, organizations usually use less distance from head, maybe 200. The key thing to point out is that the chain could technically reorganize, and that is one of the complexities that a builder has to deal with. With F3, there would be a new mechanism where a tipset can be certified to be final. Once a tipset is final, it is final forever. It cannot change, which simplifies a lot of things for the builders. The finality time is going to be significantly faster, so we are aiming for about 2.5 minutes from 7.5 hours, which is a huge improvement and opens up a whole bunch of new applications that were never possible before. And importantly, F3 aims to work gracefully alongside EC. It's not that EC goes away. EC will always be there as the backbone of the network, but the system will work gracefully between EC and F3 to essentially provide you with finality, no matter what. F3 currently is being active on mainnet, is being activated, on mainnet. This talk is pre-recorded. I'm probably busy activating on mainnet right now with folks, but yeah, hopefully we are very, very close to the final stages of getting F3 out there and active for everybody to use. Now, why this API matters to builders? The first point, which is the obvious one, is reduced time to confirmation. This is a huge improvement, enables a whole bunch of applications that require much faster confirmation time. The other one worth pointing out is the complexity that I talked about in terms of reorgs, where F3 would guarantee that reorgs cannot happen anymore, and this is in line with the sort of financial guarantees that exchanges require by law in order to provide their services, and we're hoping that this makes a huge difference in terms of the quality of service offered by exchanges, both in terms of security as well as the confirmation time. The lower confirmation time also means much better user experience. Faster feedback loop when you're building UIs, and there is no need to handle things like asynchronous tasks that the user has to come back and check and things like that. And above all, you take the guesswork out of calling something final. So there is no, determined distance from head that is considered to be sort of final, but might not happen, might happen, this type of thing. It is all very simplified, which is great looking at it from a builder's perspective. It offers competitive advantage over other applications that are built on top of Filecoin. It offers a whole new opportunity for building new applications that weren't possible. That is really exciting to see. So you can think of like live chain explorers that take into advantage the finality in distributed applications on top of Filecoin network. Subnets becomes a thing. Checkpointing something would basically take a matter of minutes, which is essentially a latency within the subnet in the network. So it is exciting. I'm personally excited to see what builders like you can build on top of this core foundation that we have introduced in Filecoin protocol. And last but not least is future-proofing development on top of Filecoin, because the way that we are integrating F3 into APIs is going to be graceful. We are minimizing the need for code changes, and once the F3 is active, everyone would hopefully start taking advantage of F3, even if they're not aware of it. So that's been one of the key design goals that we're striving for. Just not too many code changes, apart from, of course, the new shiny APIs that I'm going to talk to you about. So, evolution of Filecoin APIs. Filecoin has gone through a lot of growth over the last few years, an API reflects that. So we've got a large API footprint, which shows different APIs that do essentially similar things but slightly different things. And a result of that is complexity in terms of implementation in the backend. So we've got the verbose API, and then we've got the complicated implementation in the back of it to make that verbose API work, which not only drags down the performance for the end users, but also makes the maintainability of the software a little bit harder. All of that translates, of course, into friction for builders that we are aiming to ease here. But all of this is not so bad. It's just growing pains of any maturing ecosystem. What we see with V2 APIs is a opportunity to kind of take advantage of all the experiences that we've got so far in V0 and V1 APIs and make a user-friendly API that has deep awareness in terms of F3 and what it can offer to the network. We are designing it with the mindset that APIs would change over time, so it's got to be extensible. And most importantly, any sign of a sign of a growing ecosystem is programs written in different languages. So we want the wire format to be very, very simple, such that folks that are coming from, for example, JavaScript or are used to more popular APIs like Ethereum can use Filecoin with ease without having to understand the protocol deeply. Current V2 API endpoint. A quick note on the approach that we're taking. We are implementing the simplest possible APIs first. We have a tight feedback loop going with our partners. Thank you, Zondax, for all the feedback that you provided to us, as well as Glyph. The two main groups that we are approaching are chain and state. In chain APIs, the most important API, if you like, is chain get tipset, and we have revolutionized this tipset selection using this primitive called selector that I'll expand on later. And then we experimented with this core concept of selector with two basic APIs in the state group, which is getting an actor and finding an ID, basically mapping an ID to an actor information. A quick note on Ethereum APIs. The Ethereum APIs have been ported over to V2. They support tags as the Ethereum APIs do, but there is no code changes required there. Just so you know, just change the URI from V1 to V2 and you're good to go, which is great. The key thing to point out across the API design is that they consistently use this selector pattern that I'll expand in the next slide. They have deep awareness of F3 and the consensus mechanism underneath it overall, and the interaction model is much simpler than the V1 API. So what is the selector pattern? The selector pattern essentially offers a unified way of finding a tipset, and finding a tipset is a core foundation that almost all other interactions in Filecoin API are based on. So if we can make the selection of tipset rich, then we have enriched remaining interactions with the API, and that's exactly what we are trying to do here. So tipset selector works in three ways. We can select by tag, and that tag is a string label, latest, safe, finalized. We can select by height, which is an epoch basically, and that height can be anchored to a specific tipset. So if you imagine chain is a tree and you can have heights in different branches of a tree, so this could be anchored to anything, any tag or any key, which is quite interesting. And last but not least, we've got tipset by key, which is the most concrete and specific way of selecting a tipset. These three ways of selection are designed such that they provide flexibility in terms of how the tipset is selected, just to stay true to the fact that all builders build different things and they require different requirements, different levels of guarantee. So we can't enforce a single way of selecting everything for everybody, and that's the main takeaway here. The other thing to point out is that selectors are very composable, so they could be composed with different pieces. For example, the anchor in the height that I'll show you examples of, and it provides a single unified pattern for interacting with API, which is a really nice to see feature from a developer perspective, as I'll show in the wire format. The other thing to point out is that the finality mechanism on Filecoin network is transitioning to F3. There will be activation epoch after which F3 would become active on the network, which I think is happening by the time you watch this video, which is exciting. But the other thing to point out is that we are thinking about conservative behavior depending on tags. So for example, in case of failure or in case of edge cases, what should the API do? And the diagram there shows you a quick overview of what it looks like. But a long story short, we always try and transparently do the right thing for the developer. And the main advantage of that is that as a developer, you don't need to know about the specific configuration of a gateway that you're calling or a specific configuration of a node. You just learn the conventions of the V2 API, and those are uniformly applied across implementations, and they're transparently handled in the background, which is really nice to see. So let's take a comparison between V1 and V2 APIs. What did it look like on the wire? So we have probably the most basic API in Filecoin V1, which is chain head, and returns the heaviest tip set. So on V1, there's a dedicated function for that. On V2, we just have one, chain get tip set. It's the only API, and it takes an extensible selector. In this case, we're selecting a tag called latest, which returns the heaviest. Okay, this is not too bad, right? So not so bad between V1 and V2. Let's take a look at a more complicated example. So if you want to get a finalized tip set in V1, what we have to do is we get the head, we walk back 900 epochs, then find the tip set at that height, anchored to the key of the heaviest tip set. Now that involves two API calls at least, and calls two different APIs in V1, chain get head and chain get tipset by height. In V2, this is just handled with one call, and as you can see, it is just much easier and much simpler to look at least on the wire. We've got chain get tipset, the same function as before, but we're just swapping tag with finalized. And this finalized magically handles things like F3 edge cases, EC edge cases, and will return you the latest tip set that is finalized. Let's look at a more complicated example. So we're going to get a first non-null tip set at a specific height anchored to the finalized chain. So in the V1 API, this involves at least three calls. Basically, the first two calls to find out what was the finalized tip set, as I alluded to earlier, the previous slide. And then we get the key of the tip set at a specific, at the finalized epoch, to then call another API, which is called chain get tipset after height, that handles non-nil tipsets gracefully to then find what we wanted. In V2, of course, this is much simpler. Again, chain get tipset, and we are swapping the selector this time to get by height at a specific epoch. Then we are specifying previous, which is a flag to indicate whether to jump back to the parent if the tipset at a given height is null. And then we are anchoring it to whatever is finalized. Just, we don't care about specific key or anything like that. Just if a tipset is finalized, just always follow the finalized chain, right? And that is really nice from developer perspective, because I don't have to know about internals of Filecoin at all. All I indicate is explicitly what I want, and it just happens, which is nice. So a quick slide on the ETH API. So ETH APIs on the wire format hasn't changed at all. I've shown you the example of safe here because we are kind of working on the concept of safe for Filecoin APIs. This is a new concept that we've introduced for Filecoin specifically that existed before on ETH. The main difference is that we are settling on a distance of 200 as a safe distance from head to returning tips associated to this tag. In V1 API is 30, but in V2 API it is increased to 200 just to be conservative. These are all experimental, just to point out a small difference, but in terms of wire format, these are all the same. What's coming next? So Lotus, after F3 is active, there would be another Lotus release which associates a concrete tag to the V2 APIs. It's going to be 1.33.0. There's an issue that is linked into the release. Please follow that issue for more updates. In terms of internal improvements, we are aiming to reduce a lot of the complexity in terms of the implementation of these APIs now that the V2 APIs are coming around. And this for users means better performance, for node operators means less resource consumption, and for us means much less, hopefully, maintenance costs for Lotus. And then we are going to expand the V2 APIs. We're going to work on state APIs first, because there's a lot of friction there in terms of APIs that do very similar things. So we're going to figure that one out as a group of API used the most by exchanges. And then after that, we're going to expand on other API groups and slowly increase the V2 APIs. Once V2 APIs mature, there would be a timeline for deprecation of V0 and V1 APIs with some deprecation timeline that we would be communicated to you folks. So yeah, a lot of exciting things coming. Please stay tuned. I want to thank you, all of you, for letting me take your time. Special thanks to Kuba, Rod, Orion, and Steve, folks at the team that have helped make all of this possible and work closely with me on the concepts of this API. It's been a real team effort. Of course, a lot of folks have worked on F3 to make it happen. This is just a few of the names that I've listed from the FIP, but yeah, it's been a long time coming, and I'm grateful to you all for making all this possible. If you have any questions, please reach out to Phil Fast Finality for anything that we can help you with. Thank you.